Hello, I'm, my name is John, and now I am going to present the threads concept in operating system. The introduction is a thread is the smallest unit of CPU execution. It runs within a process and shares resources. The processes versus thread. Processes have separate memory, while threads share memory within a processes. This is the processes versus thread. And now here we are going to see about the types of threads. There are two types of threads, and they are user level threads and kernel level threads. This is the type of threads, and there are some models in threads, many to one, one to many, many to many. These are the models in threads concept. And here the threads life cycle. Threads life cycle states new, ready, running, locked, terminated. This is the thread life cycle. And now thread creation. Thread creation. Thread creation is nothing but threads are created using APIs like pthreads, Java threads, and etc. This is called as thread creation. And here multi-threading in OS. It is nothing but allows multiple threads to run concurrently for better performance. This is called as multi-threading in operating system. And now here we are going to see about the advantages of threads. Some of the advantages of threads are improved performance, resource sharing, better responsivity. These are the advantages of threads in operating system. The disadvantages of threads. Some of the disadvantages are complexity, synchronization issues, debugging difficulty. These are the some of disadvantages of threads in operating system. Here, thread synchronization. It is nothing but ensures correct execution order using mutexes, semaphores, etc. Means this thread synchronization ensure correct execution order. Race conditions. Race conditions occurs when multiple threads access shared data unpredictably. At that time, race condition occurs. And what is race condition? A race condition is a situation that may occur inside a critical section. This happens when the result of multiple thread execution in a critical section differs according to the order in which the threads execute. Race condition in critical section can be avoided if the critical section is treated as an atomic instruction. Also, proper thread synchronization using locks or atomic variables can prevent race condition. This is a major security vulnerability, and by manipulating the timing of action, anomalous results might appear. The race condition occurs when multiple threads read and write the same variable. That is, they have access to some shared data and then they try to change it at the same time. In such a scenario, threads are racing each other to access or change the data. This is a major security vulnerability, and this is called as the race conditions. And now mutual exclusion. Mutual exclusion is nothing but prevents race conditions using mutex, semaphores, and monitors. Here, text blocks in threads. Of course, when threads wait indefinitely for each other resources. This is called as deadlocks in threads of operating system. And now thread scheduling. Operating system schedules thread using preemptive or non-preemptive scheduling. Thread scheduling. There is common in Java that basically decides which thread should execute or get a resources into operating system. Scheduling of thread involves two boundary scheduling, and they are scheduling of user level threads to kernel level threads via lightweight process by the application developer. And the next one is scheduling of kernel level threads by the system scheduler to perform different unique operating system function. Lightweight processes, convention scope, allocation domain, process 1, process 3, process 2. These are the thread scheduling. Advantages of TCS over SCS. If all threads are TCS, then context switching, synchronization, scheduling, everything takes place within the user space. This reduces system calls and achieves better performance. TCS is cheaper than SCS. TCS threads have one or more available LWPs. For every SCS thread, a separate LWP is associated. For every system call, a separate KLT is created. The number of KLT and LWPs created highly depends on the number of SCS threads created. This increases the kernel complexity of handling scheduling and synchronization, thereby resulting in a limitation over SCS thread creation. Static that the number of SCS thread to be smaller than the number of TCS thread. If the system has more than one allocation domain, then scheduling and synchronization of resources becomes more tedious. Issues arise when an SCS thread is a part of more than one allocation domain. The system has to handle n number of interfaces. And this about the thread scheduling. And next, threads in popular operating systems. Threads work differently in Windows, Linux, and Mac OS. In Windows, it is one type, and in the Linux, it works in different way, and also in the Mac OS, it also works in different way. This is the threads in popular OSs. Threads versus multiprocessing. Threads share memory. Processes do not. Each has advantage and disadvantage. Real world applications used in web servers, gaming, database system, and AI. Future of multi-threading. Advancement in parallel computing and multi-core processor. And the conclusion. Conclusion of thread in operating system that threads are lightweight processes that share resources within a single process, allowing for improved performance and responsiveness. And thank you.